equation was x squared plus 3x minus 28 is equal to 0. And then we ended up getting x was equal to -7 and +4 would end up being what our final answers were. And we solved this by factoring. Today we're going to look at a second way to solve quadratics. Another way to solve quadratics is by graphing. And when we graph a quadratic, we are looking for what are called the zeros. And in a second here, we'll take a look at this quadratic that we looked at yesterday and start to look at where do those zeros occur on a graph of a quadratic. So heading into, I'm going to use the program Desmos again. So if you are wanting to use this program, if you go to our schedule, and if you click on the green Desmos icon, it'll open up a window for you to use Desmos. So on Desmos, I have a couple of functions. We're going to take a look at these other ones here in just a second. But we have an x squared plus 3x minus 28. So that was the quadratic equation that we graphed yesterday. We're going to take a look at how to find the solutions on a graph. So I'm going to turn that one on. And when we are looking for solutions on a graph, we are looking for what are called your x-intercepts. So yesterday we talked about roots, zeros, and x-intercepts. X-intercepts are going to also be solutions to your quadratic. So when you graph a quadratic, you can also find its solutions by finding where does it cross the x-axis. So where are those x-intercepts? So we can see that this graph is crossing my x-axis right at -7. And that was one of the solutions we found by factoring yesterday. So this is just another way to solve quadratics. Over here, we have our second solution. We have our solution of 4, which is going to be where we factored yesterday. We got that x minus 4, and then those are going to be my two solutions. So yesterday, we went through the process of factoring where we factored this into x plus 7, x minus 4, and then we set each of those factors equal to 0, and we found it was -7 and +4. Today, we're going to start connecting that to the graph. There's going to be where my first solution is, -7. And there's my second solution, +4. The other thing we're going to do today is we're going to connect what factors go with each 0. So here's my 0 of -7. That would mean I had a factor of x plus 7. And my 0 of 4 would be coming from that factor of x minus 4. So yesterday when we factored, we would set those factors equal to 0. And then I would be able to start to solve out and find those solutions. So it's really important to recognize that roots, zeros, x-intercepts, solutions, they all mean the same thing. They're all going to be those values that make your quadratic equal to 0. So we're going to investigate a little further what these graphs of quadratics can do. Now, the graph of a quadratic is kind of interesting because it can turn. It can turn and go another direction. So what that's going to do is it's going to cause us to have 3 different options for its solutions. So a quadratic function can have 0 solutions. It could have 1 solution, or it could have 2 solutions. Now, I say that tongue-in-cheek because really every quadratic does have 2 solutions. Even though it does say 0 solutions, it does still have what are called imaginary solutions. So we are only talking about, when we're looking at 0, 1, or 2, we're only talking about the real solutions. So that's all we're in Algebra 2A. We only discuss real solutions. Eventually in Algebra 2B, you will talk about the imaginary solutions that you will get. So first, you can have a quadratic that's going to have no real zeros. So a quadratic that's going to have no real zeros could look like this. So it's a quadratic that's coming down, it turns, it never hits the x-axis. So when we're looking for a quadratic's amount of solutions, we're looking at how many times it's going to hit the x-axis. So here it does not hit the x-axis at all, which is going to mean that it's going to have 0 real solutions. So we could have a possibility of a quadratic that looks like that. And if you look at this quadratic and you would start to try to factor it, what multiplies to 7 adds to 2, you're not going to be able to find anything. It doesn't factor. So Some of those quadratics that don't factor are going to have the situation where they're not going to cross the x-axis. So no real solutions would be a quadratic that would look like so. It's not going to come down. It's not going to ever hit the x-axis. It's just going to turn, go the other way. No real zeros, no real solutions for that one. You could have a quadratic that has one real solution. So a quadratic that has one real solution is going to look like this. It's going to come down. It's going to hit your x-axis, but right where it hits the x-axis, it's going to turn and go the other direction. So this particular quadratic, it does factor. It's going to factor into x minus 3, which causes you to get that solution of 3. But since x minus 3 are both the exact same factors, when it factors, it just has that one solution, 3, 0. So the next type of situation is we can see quadratics that have just one real zero. That would be when the quadratic is going to come down and it's going to hit the x-axis and then turn the other direction. So that one real zero would just be that one spot where it's going to hit your x-axis. So the second type of solution could have one real zero. And then lastly, two real zeros. We already saw one of those today when we looked at our opening example, that one that we talked about yesterday. But one real zero would be where your quadratic is going to hit the x-axis 2 times. So we'd have a one real zero of the first one up here, but then the 2 real zeros here. Now we have a 0 of -4 and a 0 of -2. And x squared plus 6x plus 8, here's where we'd look at what multiplies to 8 and then adds to 6 when we would factor it. And that would be x plus 2, x plus 4. So those would be your factors of that quadratic. And then when you set x plus 2 equal to 0, -2 would solve that. X plus 4, set it equal to 0, -4. That's where we're getting our zeros of -4 and -2. So when we're looking today at graphing, we are going to start to recognize where are those zeros located. So that's going to be another way that we can solve. And it's a very nice way because we have a lot of graphing technology. So if we're having trouble with factoring and we're just not able to factor, we could throw it into a graph and we can now start to see where is it crossing that x-axis. So we'll practice 2 problems here from lesson 35. So we're going to find the roots of each equation, graph the related function, and describe the relationship between the roots, zeros, and x-intercepts. This we already know. Roots, intercepts, and zeros, those are all the same thing. They're all just representing the solution. So I'm not going to go through that on the notes. Those all 3 mean the same thing. They are synonyms. But we will put both of these graphs in. So I'll head down to Desmos. First one we had was x squared minus 10x plus 25. Same as yesterday, we still need to have it set equal to 0. There would be my first graph that we had in our notes there, x squared minus 10x plus 25. And on Desmos, it works really nice. We can just head over to here, check, click on the 0 there, and there it is. We'd have 5, 0 is our 0. So this one has 1, 0, and it has a 0 of 5. So here we'd have a root of x equals 5. So there would be my solution for part A. So I encourage you to use graphing technology. Find out what is that 0. Next, we have 4x squared plus 20x. So we'll head to Desmos. We'll put that one in as well. 4x squared plus 20x. And there it is. And we can go ahead and find our zeros are -5 and 0. So 0, 0 is a 0 of 0. I know I'm saying a lot of zeros going on, but that would be a 0 of 0. So our 2 zeros are -5 and 0 for our second graph there. So the big idea we're practicing with graphing is where are those x-intercepts? Yes, Morgan. Correct. You can use your graphing calculator as well. And then with your graphing calculator, you would want to go to your table. So you'd have to hit second graph, which would be your table. And then you would look at your table, you would look in your Y column of your table, and you would look to see where is Y0, and that would be your x-intercept. Sometimes your graphing calculators, they're not as high definition. It's a little bit harder to see, but sometimes you'll be able to see right where it crosses the x-axis. That's going to be where your 0 is, yes. So I previewed Delta Math, and everything that you would graph on Delta Math will be in that window on your graphing calculators as well. So you could use Desmos or your graphing calculator. And that would also be available to you on your schedule as well, where that graphing calculator icon is. All right, any other questions about our graphing? I guess I did forget to draw a picture here, but we would want a picture in our notes. 2 real zeros is going to look like where both parts of your quadratic are going to cross your x-axis. All right, heading down then into our next problem. Write a quadratic function that has zeros of -3/2 and 4. Just for to make this a little bit closer related to Delta Math, let's say we had a 0 of -3 instead of a 0 of -3/2. So when we were factoring yesterday, when you factor, you're going to end up getting factors where you have your x minus a number or x plus a number. But what you should start noticing is whatever that number is, the 0 is just whatever the opposite of that number is. So when we're given zeros, we can rewrite them as factors. We can rewrite x, we could rewrite the 0 of -3. That would come from a factor of x plus 3, because when I set x plus 3 equal to 0, then I would end up getting that 0 of -3. And my other 0 would be 4, which would come from the factor x minus 4. Now we want to write a quadratic function that comes from those two factors. So we'll set it equal to y. Well, if I have two factors, two binomials like that, I'm just going to FOIL these out. So it's going to be x squared. My outsides are going to be -4. Insides are going to be +3, which add up to make -1x. And then my last 3 times -4 end up being -12. So there would be my function, x squared minus x minus 12 equals y. And if you're unsure, you can head over to Desmos, and we would hit x squared minus x minus 12, and you'll see your two zeros, -3 and +4. So those would be our two zeros that we were given, and then now that would be the quadratic equation that relates to those. Okay. And lastly, we'll use Desmos for our last problem as well. So we've got h of t is equal to -16t squared. I'm hoping you guys have heard of Isaac Newton before. This is one of Isaac Newton's laws of physics. So that gravity that's pushing down and then a velocity that's pushing up, we can start to calculate time. It takes something to rise up into gravity and then gravity pull it back down. So it says the height of a free-falling object neglecting air resistance is given by the function h of t equals -16t squared plus initial velocity times t plus initial height. So height, h of 0 is initial height, and v sub 0 is initial velocity in feet per second. And h sub t is the height in feet at a time of t seconds. How long will it take an object to hit the ground after it is thrown straight down at a speed of 12 feet per second from a height of 108 feet? So we'll start by filling in our information. The 12 feet per second is a velocity. The 108 feet is going to be our initial height. That would be our h sub 0. So we're going to take -16t squared plus 12t plus 108. So there would be our answer. And I am incorrect on one thing here. Or no, that would be, no, I am incorrect on one thing. Since we are throwing a ball downwards, that's going to be a negative velocity. So that would be our result there. So heading back into Desmos, I'm going to graph this out. And to find our t, we're going to again look for where is my x-intercept. So we'll start with negative 16 x squared. I can just use an x instead of t. That's fine. Minus our velocity, 12x, plus 108. And there's going to be our parabola. So here's us standing way up here, 108 feet. We're going to throw our ball straight down. But all we're really concerned about is the x-intercept, which is right here. And we're going to end up getting 2.25. So our answer right here is 2.25 seconds. There's going to be how long it would take from 108 feet. If I throw a ball down at that velocity, it's going to take about 2.25 seconds. So I encourage you to graph these out, graph them, and look for that x-intercept. That's going to be our main goal today. So that finishes up lesson 35. Tomorrow we'll start our review. Today you can head into Desmos. There are Delta Math. There are 6 problems for completion. Have your Delta Math tab open too, or your Desmos tab open too. A lot of D's going around. Sorry, I'm misspeaking. You can then throw those in and practice finding where those x-intercepts are. But we are at 7:50, and thanks for your patience. We are getting into some more deeper concepts into Algebra 2, but you are free to go to work on your own. Thanks for joining, everyone. This is recorded. I'll put it up onto our class page, and have a great rest of your day, and we'll see you tomorrow for the review.